So we've just looked at solving quadratics by factoring. Now we're going to look at doing something a little bit different. And we're still going to be solving quadratics, just solving them by square roots. And we'll get into that after this little review. We're going to go over radicals, just like square root stuff. So a radical symbol is just square root symbol, looks like this. And that just means we're taking the square root of something. Pretty sure everybody's seen that before or should have. If we were to list the first 20 perfect squares, I'm not going to list all of them. We've got 1, that's a perfect square. 4 is, square root of 4 is 2. 9, square root of 9 is 3. We've got 16, square root of that is 4. 25, square root of that is 5. 36, square root of that is 6. And 49, square root of that is 7, and so on. So for simplifying a radical, so if it's a perfect square, like one of these, then you just take the square root of that number. If it's not, then you have to break down the inside of the radical to where you can take a perfect square out. And sometimes you may not be able to do that, like the square root of 5, for instance. You can't break that down anymore. It's a prime number. So in some cases, it's just really square root of 5 is your answer. So I'll show you what that looks like. And when you do a problem like case 2, if you take out the square root or the perfect square, that comes to the outside of the radical, and whatever's left stays on the inside of the radical. And for both cases here, if you have a coefficient on the outside at the beginning, once you take the perfect square or the square root out of the radical sign, you just multiply those. So we'll go through a few examples. So number 1, we've got radical 49, and 49 is a perfect square. So we just take the square root of that, and it would be 7. On number 2, we've got the square root of 225. That would be that'd be equal to 15. That's a perfect square. 3 is a good example of this last little note here. So we've got 2 outside of a radical, and on the inside of the radical, we've got 144. So that's like saying 2 times that square root of 144. And the square root of 144 is 12. So we would bring that outside of the radical and multiply it by 2. So our final answer would be 24. Anytime you have a fraction, the way that fractions work in a square root, this is pretty much like saying square root of 4 over the square root of 9. So you take the square root of the numerator and the square root of the denominator, you just keep them as a fraction. So square root of 4 is 2, square root of 9 is 3. Number 5 is the same way. This is pretty much like saying square root of 1 over the square root of 81. That's going to be 1 over 9. Let's see. Let's do some that don't come out evenly. So let's look at number 7. So number 7, we've got the square root of 112. 112 is not a perfect square. So we're going to take the inside and break it down. And two things we can use here, I guess the highest, you want to find the highest perfect square in 112 that you can divide that by evenly. And so if we took 16 times 7 is 112, so we could use 16, square root of 16, square root of 7. And then, or you could also rewrite this like this. I've seen it done this way. I've also seen it done by just breaking down the inside and leaving it under the radical like this, because 16 times 7 is the same thing as 112. I probably prefer it this way. I like doing it this way because I see it better, but you can do either way. So if we were to take the square root of what we get when we break up 16 and 7, we can take the square root of 16, that would be 4. That comes outside of the radical, and then 7 stays on the inside because we can't break down 7 anymore. So that's the process of breaking those down, and you should have seen that before. So let's do number 8. We've got 245. We could use, we need to break 245 down into two terms that can multiply together, and one of those be a perfect square, or both of them could be, but typically if that happens, it's probably already a perfect square. But we can use 49 times 5. So we'll take the square root of 49, since that's going to give us a perfect square of 7, or 49 is a perfect square, and the square root of that would be 7, and then 5 is going to stay on the inside. If you have a problem like number 9, where there's a square or a coefficient on the outside, you just break down the inside and multiply it. So that would look like this. 72 is not a perfect square, so we keep 5 on the outside, and on the inside we can use 36 times 2, because 36 is a perfect square. So we'll have, once we take the square root of 36, it now comes outside of the radical and is multiplied by 5, and then 2 stays on the inside. So this final answer would be 30 square root of 2. And the rest of them are done pretty similar. That's just a quick review of square roots. Now we're going to look at solving quadratics by taking the square root. So a quadratic equation, or when it has the form ax squared plus c equal to 0. So when we don't have just when we don't have the setup of x squared plus bx plus c, when we don't have that middle term, when that's gone, we can use the square root property to solve this. So the square root property says if x squared is equal to n, then the answer is plus or minus, well, let me say this. The answer is equal to x equals plus or minus n. So I'll show you how we do that with these steps. So you're going to isolate x squared. You want to get x squared by itself. So you're essentially solving for x squared. Then you're going to take the square root of both sides, and that will cancel out this exponent of 2. The only thing that you have to do is use this plus or minus sign to indicate that your answer could be a positive or a negative number. So I'll show you what that looks like. So on number 1, we've got x squared minus 64 equal to 0. First thing you've got to do is solve for x squared. So get x squared by itself. So we're going to add 64 to both sides. To do that, x squared equal to 64. And this is how you can write this out so that you don't get confused of what you're doing. Once we have this setup of x squared isolated equal to a number, to get rid of this exponent of 2, we can square both sides, or take the square root of both sides. And when you take the square root of x squared, it just becomes x equal to the square root of 64, which is 8. You just have to remember that you have to indicate that it's plus or minus 8. Because if you want the long explanation, if we were to plug in 8 for x, 8 squared is equal to 64, but also negative 8 squared is equal to 64, because anytime you square a number, it's going to be positive no matter what. So that's why we have to indicate plus or minus. So let's do another example. This is number 2. So first of all, you would start off by subtracting 8 by both sides, because we need to get this 7x squared by itself first, then we can get x squared by itself. So we'll be left with 7x squared equal to 15 minus 8 is 7. Then we're going to divide both sides by 7 to get x squared by itself. Now that we've got x squared by itself, we're just going to have x squared equal to 7 over 7, which is 1. Now we can take the square root of both sides. So x is going to equal plus or minus the square root of 1, which is 1. And these are These are a little bit of the easier types of problems just because they come out evenly, but we'll do some examples where they don't come out evenly. Let's look at number 4. So on number 4, we need to isolate x squared. So we're going to subtract 1 by both sides first to get x, or 8x squared by itself. Then we'll get x squared by itself. So 17 minus 1 is 16. We're going to divide both sides by 8 to get x squared by itself. And 16 divided by 8 is 2. Now we can take the square root of both sides. Square root of x squared is just x equal to plus or minus the square root of 2. And you can't break down the square root of 2 anymore, so your answer is just the square root of 2. So in number 4, x is equal to plus or minus the square root of 2. So that's an instance where it doesn't come out evenly. And we'll do 2 more just to give you an idea of the different problems you can have. So we've got 2x squared minus 9 equals 55. So we are going to first need to isolate this 2x squared. So we're going to add 9 to both sides. 2x squared is going to be equal to, what would that be? 55 plus 9 is what? 64. But we still got to get x squared by itself, so we need to divide by 2 on both sides. Now we've got x squared by itself equal to 32. Now to get rid of this exponent of 2, we're going to take the square root of both sides, which will leave us with x equal to plus or minus the square root of 32. But we're not done because this square root of 32 can break down. So just visually look past that. So if we want to break this down further, we could use the square root of 16 times 2 because 16 is a perfect square. So we can take that out. So x will be equal to plus or minus square root of 16, which is 4. And then what's left that we can't break down any further, which is 2, stays on the inside of the radical. So your final answer would be x plus or minus 4 times the square root of 2. So that's an example of when it doesn't come out evenly and it's a little bit more complicated. We'll do one more just so you can see how that looks again. So on number 6, we need to get x squared by itself first. So we're going to subtract 3 on both sides. So 9x squared is going to be equal to 108. We're going to divide both sides by 9. So we'll have x squared is equal to, that'll be 12. Now to get rid of this exponent of 2, we have to take the square root of both sides. So we'll get x is equal to plus or minus square root of 12. But you're not done yet because the square root of 12 can break down further. So if we want to break down square root of 12, we could use the square root of 4 times 3 because 4 is a perfect square. So once we've done that, we'll have x equal to plus or minus the square root of 4, which would be 2. And then what's left just stays on the inside. So 3 would stay on the inside of our radical sign. So your final answer would be x plus or minus 2 times the square root of 3. And we'll go over more examples in class. But your homework will look very similar to that. And next, we will look at some more stuff with some square roots with imaginary numbers.